And as you just heard, I'm Lenny, one of the co-founders and CEO of Protocols.io. This is one of my favorite things to do, is answering questions, teaching, talking about reproducibility, and connecting with actual researchers and students. So I absolutely love this, and I take opportunities whenever I can to actually do these in person, even though we have uh, staff at Protocols.io who are fantastic and maybe better than me, but I enjoy this too much to let other people do it when I can. So we're going to get started. My background is in yeast genetics, both experimental and wet lab work and computational. Originally math as undergrad, and then I went into grad school and accidentally learned to pipette and do experiments. Um, and it was after my PhD in Berkeley, when I went to do my postdoc, that I thought I would have the fastest postdoc ever. I had a collaboration between an MIT lab and a Harvard lab. I didn't have to do strain construction and creating the yeast cell I needed to work with. I just took it from the Harvard lab. And I thought it would be a super fast, very fascinating research results project. It didn't work out that way. Instead, what happened was that I spent a year and a half correcting one step of the single cell microscopy protocol that I was using. So we're talking about, instead of a microliter of a chemical, me needing to use 5, and instead of 15-minute incubation with that chemical, needing 1 hour. And that's a year and a half. I may be a little bit slower as a math major at the bench than others, but at that point, I've had 6 years at the bench as a PhD student. I'm not that slow, so maybe it would take you a year instead of a year and a half. But there are legitimate reasons for why it took a while. And the end result is that it's not a new paper. It's a correction of something that's previously published in a journal called Nature Methods. So it's not a new technique, it's a correction, not a new paper. That means I don't get any credit for it. And more importantly, everybody else who's using this method in yeast is either getting completely misleading single cell results or has to spend a year or two rediscovering that tweak, that optimization, because there is no easy way to share this knowledge. So I sort of, back in 2012, I sort of became obsessed with creating a central place that makes it easier to share these details. And you heard a lot from Anita about the importance of this, but that's my personal sub story. My slides. Can people shake their head yes if they can see the slides? Beautiful. Thank you so much. So what we're going to do is break this up into two halves. One is just the introduction of the problem of method sharing. And you've heard already a lot about the need for details and published research from Anita, so we can do that fairly quickly. I'll show you the highlights from at least my perspective, the key features of protocols.io and why it helps with reproducibility. We'll do Q&A, take a 1-minute break, and then that pen and paper that you brought is going to come in handy. We'll have a hands-on exercise and talk not so much about protocols.io specifically, but we'll use protocols.io for a hands-on exercise to think about sharing instructions and methods. And we'll talk about best practices for whatever platform you're using. We'll talk about best practices. Now, a professor from Canada has a blog post on this where he says that our method sections are essentially this: how to draw an owl, draw 2 circles, fill in the rest of the owl. And he says that the equivalent typical method section for drawing an owl in a research paper would be something like, we draw the owl on 60.2 GSM white paper of the A4 dimension using 3H and 6B graphite pencils from Cumbria, UK. We did so by looking at owls and drawing what we saw on paper. This protocol yielded 1 drawn owl. And that's a typical method section, but it doesn't give you everything you need for actually drawing the owl. And One of the other favorites that I have on this in terms of reading published literature, this is a biologist at UC Riverside who's reading a paper and says the method section in a 97 paper references another one as described in 96 for the method. He finds the 96 paper as described in 87, finds 87 paper, and it's too old, paywalled. Even University of California doesn't have subscription to it. That is a very common and very frustrating experience, not just specific to biology. Here's a physicist reading paper, and the method section is devices were fabricated as previously described, previously described, previously described, and the original is devices were fabricated with conventional methods. So good luck with that. And I have a really long collection of tweets exactly like this that I've been bookmarking and putting into a thread. It would take us the entire hour to just go through them. We won't. But I'll finish the introduction in terms of the difficulty with method sharing. I'll finish it by talking a little bit about pretty extensive, Anita knows about this, pretty extensive effort that started, I think in 2015. It was $1.5 million, and it was an initiative to repeat independently experiments from 50 cancer papers in top journals. And it was done by Center for Open Science and Science Exchange in collaboration. And after the first year and a half, they published the first 5 replication results. And there was a lot of media coverage of it. And one of my favorite science journalists, Ed Young, when he was writing about it, quoting from his article, he wrote, "The hardest part by far was figuring out exactly what the original labs actually did. Scientific papers come with method sections that theoretically ought to provide recipes for doing the same experiments, but often those recipes are incomplete, missing out important steps, details, or ingredients. In some cases, the recipes are not described at all. Researchers simply cite an earlier study that used a similar technique." And in fact, just a year later, the whole initiative, instead of doing the 50 papers they were aiming for, shut down at just 18. And a large part of it was that it was exactly as you saw on the slide above. Even when you were collaborating with the original labs that published the paper you're trying to reproduce, it is hard to figure out, even for the PI, for the professor, even for the people in the lab that published the paper, it's hard to figure out exactly which protocol was used in this particular paper. The student, researcher, postdoc who did the work is often no longer there. You're digging through lab notebooks. You don't have the exact precise link to the step-by-step instructions with the RRIDs, with the needed reagents, right? And the level of detail that you really need for building on someone else's work. So it's really hard to do. And I think of this as sort of 2 challenges. One is external reproducibility and one is internal. The external is when we publish other people reading our work, can they repeat it? But my favorite quote when we teach reproducibility workshops is, your most likely collaborator is you in 6 months. And so I think of the internal reproducibility. Can you repeat what you published? Can people in your lab, right, internally in the research group, can you do it? And both are very hard. So it's not just, oh, it's the journal's fault, that if we could only make method sections better. It's also about the best practices. It's also about being organized and paying attention to these details, recording them as you're doing the work. As Anita was saying, right, talking to the statistician, not after you've done the work, but before, right? And keeping track of the details as you perform the experiments, as you do the research, not trying to dig back through your lab notebook and figure out what exactly did I do. So the mission of protocols.io is to make it easy to share these method details before, during, and after publication. Because of external and internal, there's sort of 2 sides to protocols.io. There is the open access repository. And if you're sharing, just to be upfront, what the sustainability business model is of protocols.io, if you're sharing any method publicly, it is open access, free to read, free to publish. We don't charge anyone for that. But if you're using us exclusively for private collaboration, then you have a certain number of 5 free protocols. And after that, if you try to create a 6th free one, we ask you to either make some of your protocols public or pay a small monthly fee for private use. So we have just over 10,000 public protocols at this point. We launched in 2014, and over 30,000 private ones. Can I ask if everyone created a protocols.io account? I'm seeing heads nodding. Excellent. So we will use that. Most of the platform, hopefully all of the platform, should be intuitive. You don't need Lenny or a demo call to understand the features. If you want to create a protocol, you should, once you sign in, you should see that plus button that says create right in front of you. You can figure most of these things out. Like when you buy a new phone, you probably are not reading the detailed guide. So I'm not going to go through all of the buttons and, in depth. Here's how the editor works. This is not an advanced training of the platform. We do those. But what I do want to highlight, I want to do a live demo. What I do want to highlight is some of the functionality. You should still be able to see my screen, but no longer in the slides, but now just the website itself. And what I do want to do is just highlight some of the key functionality that I think is the biggest impact, is the key to improving reproducibility. So from what I'm showing you are public methods, but anything you create by default is private, starts out privately, like a Google Doc. You decide who to share it with, when to share it, what kind of permissions. Is it view only? Is it view and edit? So you decide what permissions, who to share it, and if and when you're ready to make it public, great. You can do that, but you don't have to, and it's all secure and private in the beginning. So in the demo, what I want to highlight is that protocols are different from papers. These are not just PDFs, what you see on protocols.io. They're dynamic and interactive. And you'll see it particularly with the exercise we'll do in 10 minutes, why this is important. So what you'll see is there are components inside steps, reagents with RRIDs, materials section, safety information. There are components for the amount of a reagent that you're adding. So it's not just plain text. And as you mouse over, if you can see that, if you mouse over any step, you can ask a question, you can add a comment, you can ask a question that will go to the author and everyone who's using this technique. And this is a good example. Here's a protocol from a student at the Australian National University, where the original version, step 24, it doesn't matter what the protocol is about so much, but the instruction said, do something for 2 to 2 minutes. The timer said 7 minutes, right? And if you're cooking, this would be a confusing instruction. So one of the scientists looking at this clicked on the step and said, wait, what does it mean 2 to 2 minutes? Should it be 2 to 7? The author replied, whoops, that's a typo. It should be 2 to 3 minutes. And this is a public discussion that's happening. You can ask, when you click ask a question, you can ask privately, but this is by default, it's public, right? And what you're doing is, instead of answering the same question over and over by email after you've published something, you're answering it here. You can direct people to the answer, and hopefully people won't ask it because they're seeing the discussion right there. And importantly, with the click of a button, the student is able to create a new version. And the discussion is still there, but she creates a new version. If you go to the drop down at the end of a title, there is a compare button that allows you to compare any two versions. And this is also where the components become handy as opposed to plain text, and allows you to see which steps are the same, which ones are different. And that's a bird's eye view, right, of what's different between the versions. So the versioning functionality is for the owner, for the author and co-admins, your collaborators on the protocol. I cannot come in and obviously cannot come in and create a new version of your protocol. But for every public or private protocol that you see, what I can do is click the copy fork and essentially use any protocol in protocols.io as a template. So if you are working with kidney cells and I'm working with liver cells, we might have slight tweaks and variations between our protocols, and that's what the forking functionality is for. So I can create a copy of this protocol, it becomes private to me, then I can go into the editor, and maybe it's the equipment in my lab that's different, but I can make a private copy of the protocol, use it as a template, make the modifications as necessary, and then if and when I'm ready, share it publicly. And you can see in this example itself, under the title, it actually says this is fork from another protocol. Right? So this itself is a fork, even though it has multiple versions. And there is a tab for forks where we try to make sure that we show you what's the evolution of this protocol, make sure that everyone gets credit, both the original authors and the people who make modifications. The last thing I want to highlight in terms of protocol level functionality relates specifically for wet lab protocols. We do have a lot of computational pipelines. We're not competing with GitHub, but a lot of people share computational workflows where they record which software did they use. Here's the Python code, here's a link to GitHub. We analyze the following data set, which version of the mouse assembly. We ran BLAST for sequence comparison. What are the parameters that we used when we ran BLAST? What were the cutoffs? So we do have, I think out of the 10,000 protocols, about 5 to 10% are computational. But for the wet lab ones, which is the majority of what we have, there is a run button. And this is the part that lets you, sort of like a cooking checklist app, that allows you to step through the protocol as you're doing the experiment on that particular day. Right? So done with step one, what am I doing next? So you see where you are, what's next. If you have a timer, you can have your iPad or Samsung tablet directly in the fume hood, started right there. So this lets you walk through. If you have used components for the amounts, and today you're doing 15 samples instead of one, you can scale all of the amounts inside the protocol. So there are a lot of powerful features, but the runtime functionality also lets you take notes as you're doing it. So not changing the underlying protocol, but to say, today I did this incubation for 5 minutes instead of 7. And then you have a sort of lab notebook-like entry of how exactly you step through the technique on this particular day. So those are the key protocol features that I wanted to show. And before I stop for questions, I do want to highlight that not only do we let you create and share protocols, but we also let you start communities, workspaces for your lab, or more broadly for a community of researchers. This is one, for obvious reason, that started just over a year ago, and this is method development community of coronavirus researchers. And what you can see is at the top, there are more than 500 members. There are 250 publicly shared protocols. And I really want to highlight the very first coronavirus protocol that we got in January of last year. It's just a beautiful example. It is forked from an Ebola sequencing protocol from the same group, and you can see it at the very top, that the researchers shared back in 2019 before there was any COVID. They had been to Africa. They were doing Ebola sequencing, funded by the Wellcome Trust. They're part of a consortium of pathogen surveillance labs that have been sharing public protocols on protocols.io since 2017. They shared the Ebola protocol, and as soon as coronavirus came on their radar, they tweaked the Ebola protocol, and you can see this one is very extensive, right? A lot of components, a lot of steps, and it takes time to share something with 100 steps like this. But because they already shared the Ebola protocol, it didn't take them long at all to make a fork of it. And you can see this is fork, to make a fork of it and share the optimizations, the tweaks that are necessary for working with SARS-CoV-2. And again, the same compare functionality works not just between versions, but also between forks. And you can see, oh, why is it misaligned? The danger of live demos instead of screenshots. But what you can see is that in step one, for the Ebola protocol on the right-hand side, they had used 10 microliters of the genome. With the SARS coronavirus sample, you need, am I looking at the right version? I think it's the version that's the issue. They changed it too much. Which is also wonderful to see that as they were optimizing the protocol, they kept sharing new versions of it. But you can see that from Ebola, where they used 10 microliters of the RNA, for coronavirus, you need 11. And that's a tiny little difference, right? And then the next steps are the same. Tiny little difference, but it's important. And the ability, and this is what I think is so important about protocols.io, the ability to capture these tweaks and optimizations, and the fact that you can use any protocol as a template lets you quickly share these corrections and optimizations with others. So I will go back. I have the backup slides in case live demo doesn't work, but we've gone through. There in the slides at the very end, you'll see screenshots of the functionality, but we've gone through most of what I wanted to cover in this part. And I do want to mention that there are now a lot of journals, over 500 biomedical journals, that recommend or encourage in author submission guidelines that you share a link to the details on protocols.io specifically. More and more funders that expect grantees to share protocols that come out of the work, and more universities that have site licenses that cover you both, not just for the public use, but make the private use free as well. And with that, I will pause for Q&A. So when doing the demo, I should have shared, not only can you share images and videos, we welcome that warmly. We are starting to see more and more videos. I think they are very important for reproducibility. I think they make a huge difference. I think they make a huge difference. Will I be able to find what I want right now? Particularly because not everyone is a native English speaker, and including videos in your protocols really helps with accessibility. It helps with reproducibility. So you can put a link from YouTube. It'll render right in the step. But there are also more and more protocols we see where someone carries their phone into the lab, takes a 10-second video, drops it right into the step. Again, we'll host it on Amazon, render it. And this is really important for reproducibility. We have images, tables with formulas are supported, videos, and I'll talk a little bit actually in the next 20 minutes about, I actually do talk about the importance of videos in my best practices, but we support it, welcome it, and we think it's very important. So let's go back to screen sharing. When you have a moment, do upload yours because it's just a lot of fun. And I love adding them to, right? These are the instructions. And from just some previous workshops, this is just a sample of what we come out with. I think this one is mine on the right-hand side. I maybe guessed that it was SpongeBob, maybe not, I don't remember, but it's not trivial, right? But the point here is we had step-by-step instructions. They were on protocols.io, but they're not very reproducible. And the key of this exercise is really realizing that just because you've shared it on a platform does not make the method itself reproducible, right? Did you include the reagents? Did you put in a video? Do you have RRIDs? Did you follow best practices? And more importantly, it's when people ask us questions, when we share, when we evaluate what are the results others got, how does the protocol work, and not in my hands because I've been doing it for 3 years now every single day. I can do it in my sleep. Can other people follow instructions, right? When you look at what people are getting, you quickly realize, even without questions, ooh, the instructions we gave are imprecise, right? So when I say draw something, when I see what people are getting wrong, it's very easy to go back to the instructions, spot the ambiguity, and make it more crisp, right? And make the instructions better. And there is no point in these best practices that I can stress more than just to say, whatever platform you use, Protocols.io or anything else, make sure that you conversion, because the big feature of a method compared to a paper is the methods evolve. They're sort of living and breathing features. Our equipment improves, antibodies change, software changes, algorithms are improved, right? And these are not static. They improve. You improve how you detail them, and whatever platform you're using, you can try your best, but the first version you share, you will get questions if other people are using the technique. It's an art of writing methods, and it is an iterative process where you see what is not working for people. You said invert the two, but without a video where you show how you're inverting. Is it inverting like this with a snap of your hand, or is it a very gentle invert? You might not even be consciously aware of this, right? This is one of the reasons why videos do help a lot, like Justin said. And the key part here is do digitize. You might be using Protocols.io. You can use Google Docs. I don't recommend using Microsoft Word because the versioning is not as trivial, sharing and versioning. Google Docs is much better. I am, as a co-founder of Protocols.io, obviously very partial to our platform. And we've built in not just support for videos and components, but for wet lab protocols, there are a lot of reagent vendors that gave us their catalogs. Adgene gave us all of the plasmids. So we do try to make it easy for you to capture those details. But whatever platform you're using, um, try to make sure it's versionable. And you want to think of a protocol a little bit like a publication itself. The methods section in a paper is kind of an abstract for what you've done. We essentially never put all of the critical details that need to be there in the method section itself. And not everyone needs, unless they're repeating your work, not everyone needs the 20-page protocol for all of the weeks that you were doing with step-by-step instructions. It's the people that will be replicating the work. Very often in the paper, all you need is to get a sense of what techniques were used, are they appropriate for the paper, and a link to the really detailed step-by-step instructions. So this doesn't replace Protocols.io, doesn't replace a method section, but this is how I think of method sections as sort of an abstract. And the protocol itself is kind of a little self-contained publication. You do want to include abstracts in your protocols. just as you would for a paper, so people know what the technique is for. Is this one because there are 10,000 public protocols on protocols.io? You're helping people a lot if you put in an abstract, just as you do with a paper. In terms of including as much detail, we already talked about videos and why they're important, and images. So do include those details. Protocols.io by default is chronological, right? Step-by-step instructions. In contrast to method sections, which are condensed into paragraph form, they're past tense, they're much harder to sort of convert back into the protocol. And if you go to the slides, by the way, that I shared, we have a whole guide. I'm going through this pretty quickly, but we have a whole guide with best tips and tricks and recommendations for sharing reproducible methods. So there is a link at the bottom of the slide. Use active voice, make it step by step. And again, because there are thousands and thousands of protocols in the repository, not just the abstract, but think of keywords. If you want other people, if you're sharing publicly and you want other people to find your method, you might say HPLC in your protocol. Somebody might be searching for high performance liquid chromatography. Think of the synonyms, think of what kind of researcher would want to see it and what might they be typing into the search on Google or on protocols.io so that your protocol is indeed discoverable. And of course, when it comes to recipes, the additional notes, right, the tips and tricks, they're important. But because this is not on protocols.io specifically, it's not just a Word document that's all, one blob of text. There are sections. There are step by step, there are the steps of the protocol, then there are guidelines, safety warnings. And the reason we broke it up that way is because you should think of the reader. Is it for yourself or is it for somebody else? And if you think of yourself, you're using the protocol every day. So the tips and tricks, references to other papers, right, the larger context, you don't need it every single day as you're running through the technique. You're familiar with it, you just need the steps. So think of what does a person who's looking at the protocol for the first time need? What are the essential instructions step by step? Keep the steps concise, and then the accompanying information, richer context, information that's important for a first time student, rotation student, intern who's joining your lab. Um, Put that into guidelines so that when you click run, you don't have pages and pages of text as you're stepping through the protocol, or if you're exporting it and printing out just the steps, make that easy. And going back to our exercise, you will never get it perfectly in the beginning. That's fine. This is science, right? We build and build on our previous results. And so get feedback from others in your group, your collaborators, and eventually people who are using what was clear, what wasn't clear. Can you follow these steps? Right? And the most obvious, but sometimes people don't do that, when you've put in a protocol, go into the view mode and take a look at it, because it looks a little bit different. You'll spot what in the editor might have looked okay, but when you're in view mode, is it still formatted normally? Can you see the video and images? And again, in the slides, we have a little checklist and a link to the guide for sharing reproducible protocols. Take a look at these workspaces, possibly join them. These are all open, and well, some of them I think you request to join, some are totally open, but take a look. They're all sharing public protocols. There might be some that are already relevant for you, and see if you want to join any of these spaces. And I will stop screen sharing there and want to genuinely thank you for taking the time.